Greetings, STEAM cadets. Professor L here, your head mentor at the STEAM universe. Listen, we have an absolute emergency on our hands. Our academy's security system has completely failed, and we need your help. Today, you aren't just studying technology, you're stepping up as electrical engineers. Welcome to Mission 005, which perfectly lines up with your Grade 9 CAPS curriculum, specifically the GEC 2026 Technology Worksheet 5A. Your mission today? Build a working alarm system from scratch and restore our security. We can do this.
We've got an intruder detected alert flashing in the command center right now. The stakes are incredibly high, and we need to secure the STEAM universe immediately. But don't panic. Just remember this one crucial lesson. Every single great engineering invention, no matter how complex it seems, starts out with incredibly simple ideas. Today, we're literally taking basic, everyday components and transforming them into a powerful security device.
Here's our flight plan for this explainer. 1. The mission, design brief. 2. Specifications and constraints. 3. Meet your equipment. 4. Building your alarm system. 5. Testing and troubleshooting. And finally, 6. Mission debrief.
Let's dive into Section 1, the mission, design brief.
Okay, so a design brief. What is it? Basically, it's the absolute foundation of your entire project. It is a short, crystal clear statement that describes exactly what you are going to design and make. Think of it as your starting point, right? It's not a long step-by-step list of instructions. Instead, it's just a concise paragraph that sets the direction for your whole design process. To write a really good one, you have to answer 3 key questions. What exactly is the problem? Who has the problem, meaning who is your client or user, and why must it be solved?
Let's actually look at the difference between a poor plan and a professional one. Listen to this poor brief. I'm going to make a bridge. Yeah, that is way too vague. Now compare that to a correct brief. We use a really powerful sentence starter here. I am going to design and make a simple temporary pedestrian bridge for primary school children and parents so that they can cross the busy streets safely without interrupting the flow of traffic. Do you see how that perfectly answers the what, the who, and the why? That is exactly how you're going to approach designing our alarm.
Moving on to Section 2, Specifications and Constraints.
So the absolutely crucial thing here is understanding the difference between these two terms. Specifications are your what you need list. Think of them as the job description for your product. They describe the features you absolutely must include to make it work. Using our bridge example, a specification would be that it must hold at least 10 children at once, or that it has to be made of weather-resistant materials. Constraints, on the other hand, well, those are the what you're stuck with list. These are the rules of the game. They are strict limits you just cannot change. Common constraints in technology are things like time, budget, and materials. For example, a constraint might be that the bridge cannot cost more than 500 Rand, or it has to be finished in exactly 3 weeks. As an engineer, you have to work within those boundaries.
Section 3. Meet your equipment. True professionals always verify their gear before they start building. For this informal assessment, you are going to need a 9-volt battery, a buzzer to give us that loud audible alert, connecting wires, an everyday clothespin, which is actually going to act as our switch, some electrical tape, a wooden board for mounting everything, and just a small piece of cardboard. Do a quick check of your stations and make sure you've got the whole shebang.
Before we start assembling, it's time for a cadet challenge. We are tapping into our 21st century skills right now, specifically critical thinking. You'll notice we need to strip the ends of our wires using a wire stripper. But I have a question for you. Why do we only remove the outer plastic insulation from the wires and purposefully leave the inner metal intact? I want you to pause this explainer, use your metacognition, and really think about it. Okay, did you get it? We remove the insulation to expose the metal conductor so the electricity can actually flow. That plastic insulation does a great job protecting us and stopping the electricity from going where it shouldn't. But for our circuit to connect, bare metal literally has to touch bare metal. Excellent deductive reasoning, cadets.
All right, Section 4, building your alarm system. Let's get to work.
Here is our step-by-step master plan. First up, we'll securely tape both the battery and the buzzer down to our wooden board. This just keeps our workspace nice and tidy. Second, we're going to wrap our newly stripped wires around the clothespin to create an improvised switch. Third, we connect that wiring to the battery. And fourth, we route the whole thing to the buzzer. Let's take a closer look at how this clothespin switch actually works.
This part is pretty genius. You take one stripped end of a wire and wrap it super tightly around the frontmost divot of the top clip on the clothespin. Then, you do the exact same thing to the bottom clip with a completely separate wire. Make sure to twist that bare metal tightly so it's really secure.
The magic here is that when the clothespin naturally closes, those two bare metal wires will physically touch. That physical contact completes our circuit, which is exactly what will eventually trigger your alarm.
Next up, we take that bottom pin wire and connect it straight to our power source, the battery. Position the bare wire so it's touching the positive terminal of the battery directly. Look for the little plus sign, you can't miss it. Then, use a piece of electrical tape to fasten it down securely. If your battery happens to be in a cradle, no problem. Just attach the wire to the positive connector wire of the cradle and tape it up. Remember, a secure connection is an engineer's best friend.
Now for Section 5, Testing and Troubleshooting.
Okay, to test our alarm without driving everyone in the academy completely crazy, we need to artificially break the circuit. Cut a medium-sized piece of cardboard and slide it right between the closing jaws of the clothespin. Because cardboard is a non-conductive material, it instantly stops the electricity from flowing between those two wires. Your buzzer should be dead silent right now. But when an intruder opens the door, this piece of cardboard gets yanked out, the pin snaps shut, the metal touches, and bam, the alarm sounds.
But hey, what if you pull the cardboard out and silence? Nothing happens? Well, it's time to put on your circuit detective hat. If the alarm won't sound, the very first thing you do is check for loose connections. If the wires are barely touching on the clothespin, you need to wrap more wire around it. Still getting nothing? Your battery might just be dead, so swap it out for a fresh one. Oh, and a quick safety tip. Once everything is working perfectly, cover any remaining bare wires with electrical tape. Touching bare wires while a circuit is fully engaged will give you a shock, and keeping our cadets safe is top priority.
Finally, Section 6, Mission Debrief.
Let's trace the path of the current here, and let's pretend we actually are the electricity. We leave the battery, traveling right along the wire. We reach our clothespin switch. Because that cardboard intruder trip has been removed, the metal wires are touching, meaning the switch is closed. We continue our journey straight into the buzzer, which triggers that loud audible alert to scare the intruder away. Finally, the current travels all the way back to the negative terminal of the battery, completing the full circuit. That right there is a perfect, uninterrupted flow of electricity.
Mission accomplished, STEAM cadets. You have successfully built a working alarm system, you've totally mastered the design brief, and you've secured the academy. Fantastic job. But before I let you go, I want to leave you with one final metacognitive challenge to get you thinking. If you wanted to upgrade this exact alarm system so it detects a fire instead of an intruder opening a door, which specific sensor component would you swap in for that clothespin switch? Think about it. I'm Professor L, and I will see you on our very next mission in the STEAM universe. Keep building.